My colleague Paul Léger and I will take you through this presentation, which was co-authored by Sarah Strom. We are from Kiel University, which is located in North Germany on the Baltic Sea. Our CRIS team is part of the administrative section of the university, and we are hosting Pure on premises, and it has been running in production for roughly the past 2 years. After my short introduction, I will start by laying out our CRIS project's history, its integration with our content management system, and finally, we will be taking a closer look at how we were able to solve some evolutionary problems with our supervisor data using the new Pure Update application programming interface. Our original project mandate was quite straightforward: implementation of Pure with decentralized data entry and centralized data storage and reporting. A centralized Pure portal was not part of the mandate. Kiel University's web presence is driven by the open source content management system named Plone, and each organizational unit and each researcher is responsible for their own content. We did find one commonality. Static publication listings were being presented by each researcher in a variety of citation formats on their web pages. So, working closely with our computer center colleagues, we sought out a way to replace those static listings with content from Pure. Researchers at our university were already experienced embedding content into their Plone web pages, for example, YouTube videos. The company YouTube, in this case, acts as a so-called OEMBED provider and Plone as an OEMBED consumer. Our computer center colleague, Dr. Ulrich Schwarz, developed an Owenbed Server, OEMBED provider for us, and thereby allowing Pure content to be embedded into Plone. Our exact definition of Pure content will be elaborated on in a few minutes. With our Pure Plone integration, we are able to provide our researchers with a clear proposition. By entering their research output into Pure, they are relieved of the burden of complex reporting, and they remain in control over their web page content that will be delivered in a professional, curated form via Owenbed. And now, it's your turn.
Continue. Yeah. I'd like to start by taking a look at this generalized model. On the right side of the model, our interface is used in some way for getting data into a system. And on the left side of the model, interfaces more directed at getting data out of the system. In the inner triangle, we have data entry for adding content and data views for retrieving, searching, filtering, and sorting the content. In this inner triangle, we tend to find manual interfaces. In the middle layer, within the larger triangle, we tend to find functional interfaces with data input on the one side and data usage on the other side. The outer level contains programming interfaces. The web services operating on a programmable level are used for retrieving, searching, filtering, and sorting content, just as the case with the data views at the manual level. In the early phase of our project, we worked intensely on retrieving data from foreign systems at a programming level and using Python and performing data entry into Pure at a functional level with bulk import and synchronization. We followed a pattern of data processing that could be described as retrieve, store, analyze, and deliver. At the top of the screen here, we are retrieving data from foreign systems and storing them in a data hub, a SQL database. The analysis of the data at the bottom right is being performed manually using Microsoft Access, and the cleanup process is supported by Python jobs. The delivery phase is performed using synchronization or a two-step process of producing pure XML and then bulk importing it into Pure. Working in this pattern of retrieving, storing, analyzing, and delivering the data, we acquired experience at a functional and programming level within our team. By definition, OEMBED is a format for allowing an embedded representation of a URL on a third-party site. And for the purpose of this presentation, the third-party site is our university's Plone system. The URL representation is a list of publications originating from Pure. Over the past 2 years, researchers have been diligently replacing static content in their web pages with Owenbed links, thereby replacing static content with real-time data originating from Pure. This tight integration between Pure and Plone is being carried forth as the university migrates to TYPO3, the chosen successor content management system. TYPO3 also functions well as an Owenbed consumer. This diagram outlines our Owenbed system. At the bottom of the screen, it's the representation of 3 separate systems. To the right, Pure. In the middle, the content management system Plone, and to the left, a browser being used to open and display the web page from Plone. In this schematic, the researcher has replaced his or her publication list, static publication list, in Plone with an Owenbed link. When the browser subsequently opens the web page, a series of events are initiated. Plone, acting as an Owenbed consumer, sends a request to the Owenbed server above. The Owenbed server passes the URL to a Python program running on the server, and Python posts a request for the desired research output to the Pure web services. The publication list is returned is sent via the Owenbed provider to the browser and displayed in an iframe in the web page. The somewhat complex series of events, chain of events, runs depending on the length of the resulting publication list in under 1 second. I'd like to take a closer look at these 3 components here that are highlighted in red: the Owenbed link, the Python program running in the background, and the resulting publication list to the left. Okay, the Owenbed link. Our computer center developed an app for researchers which enables them to generate an Owenbed link by filling out a form. Shown here to the right, the researcher selects their name and the desired publication listing options. The format, the Pure Web Services support 17 publication rendering formats. The sorting, the researchers can choose from 1 of 15 sort orders, and the publication period is from to specified year range. Once they are satisfied with the resulting publication list previewed in the screen below, the researcher implements the resulting link in their web page in Plone. Here to the left, the anatomy of a sample link. At the top is the target server name of our Owenbed provider. The name of the Python program to be initiated in blue, chris.py, and the search parameters that the researcher has selected. For example, the format APA. We're well aware of the fact that this offering is a rudimentary starting point for our researchers, and to fulfill more complex requirements, our CRIS team composes complex links manually on an on-request basis. This includes links for research teams, clusters, and organizations. The Owenbed server in our computer center is a Linux server running an open source version of iframely. The Python program running in the background performs the following tasks. It receives a parameter list from the Owenbed provider, constructs the query XML, and posts the query to the Pure Web Services endpoint. and handles a response. It formats the HTML and returns it to the Owenbed provider. Let's take a closer look at what we're talking about with posting and receiving. At the top here, the query XML with the parameters received in the Owenbed link, inserted in blue. This request is posted to Pure. You can more or less see that here in the blue. Those are the parameters that were selected by the researcher. And here below, an excerpt of the data which is being returned from the Pure Web Services. Here is the first publication from the list with the HTML contained in a C data block. The HTML is extracted and assembled into an unordered list and returned to the calling service. And here is a look at the publication list, what it might look like when being displayed in a browser, 3 publications in APA format. Our computer center colleague, Dr. Ulrich Schwartz, developed this Pure Plone integration solution, and our CRIS team has assumed responsibility for the user app and for the Python program running in the background. The computer center has remained responsible for the Plone and Owenbed services.
After more than 1 year of having Pure in production and using the technique for embedded listings just described by Paul, our users started indicating that unwanted publications were showing up in their listings in Plone. And we requested them to provide examples, and it became quickly clear that we were dealing with thesis publications supervised by these researchers. And the Supervisor Section for thesis publication, as it is now in Pure, was introduced after our original Pure version. And we have older imported publication, and in these publications, the supervisors appear in the contributor section of the publication. Here you see an example. To the left, we see 1 author and 2 supervisors in the contributor section, and the supervisor section is empty. And to the right, you see what this publication looks like in APA format, and it shows incorrectly something that looks like 3 authors. So we were faced with a complex situation. After original bulk imports back in 2018, we had, which resulted in 60,000 publications. Our publication volume has risen to over 70,000. And with more than 7,000 thesis publications in our system, it became quite evident that we needed a more detailed analysis of the problem to move on.
By utilizing our retrieve, store, analyze, deliver pattern of systems development, we took a closer look at the situation. In this case, though, we were retrieving data from Pure, storing the data in an SQL database, analyzing the data to identify the affected publications. The next step became a matter of correcting the data in Pure using the new Write API. Here, the first step, retrieve, we query the Pure Web Services for itemized data of theses publications. In the query, we stipulate the desired fields, contributing authors and their role and properties, and supervisors, including their role. The offset will be incremented by 50 for each query until all the requested publications have been retrieved. Here we're starting at offset 0. We're retrieving 50 publications. The next call to the API will be offset 50, retrieving the next 50 until we've retrieved all of the publications. Here's an example of data retrieved by the query. In the contributor section of the XML, we see here 2 persons, one with the role author and one with the role supervisor. That would be a correction candidate. Here's a second example of a publication that meets our current requirements. one author in the contributor section, and in the new supervisor section below, 2 supervisors, one with the role advisor, one with the role supervisor, respectively. We store this data in a SQL table defined here. The universal unique ID for each publication, together with the quantity of contributing authors, quantity of supervisors, and the quantity of contributing authors with the role supervisor. With the desired data in the SQL table, we now begin analyzing things. The select command at the top of the screen identifies 4,900 publications in our system that require correction. The publications listed here contain 3 contributing persons, no supervisors, and 2 of the contributing persons have the role supervisor. The next step in this process is to correct the data in these 4,900 publications by moving the 2 supervisors over to from the contributor section over to the supervisor section of the publication. We perform this operation using the Pure Write API. The Pure Write API is somewhat new. In Pure 5.24, we find version 0.1 early access available for use. New for our team is the JSON data syntax and the put and delete, update, or write methods. The programming documentation in our version of Pure was limited to organizations and external organizations. However, we didn't let that stop us. The Python update program performed the following operations for each of the 4,900 publications. It retrieves the publication data in JavaScript object notation. In the data definition, it then creates a new supervisor's property and moves the desired person data to the supervisor property. Finally, the program writes the updated properties back to the write API using the put method.
Here we see another example of a publication before the update with 3 persons in the contributor section. And here, after the update, publication has now 1 contributing person and the supervisors are now correctly contained within the supervisor section. What we were not expecting were the 2 organizational units to remain in the contributing section, but it does, however, conform to the pure data model, so we decided to accept our update results as correct. And that was the last slide. I'm sorry, there are some smaller problems with the layout occurred that has happened somewhere in the transfer. And that was all we wanted to say about our project, its integration with the content management system and the use of Pure API.